Okay, hello everybody again, and we are go with the next session. So today is day 3 of the Tech Month. So we still have one day coming up. So now we're going to talk about the DevSecOps throughout your OpenShift environment. So I think we've seen a real use case, more of an infra use case. We'll review some things more on the OpenShift side today, and everything around that. So I'm here today with a team of solution architects from Belgium. So we're all based in Belgium and covering the Belgium and Luxembourg market. Together with Edward, Dieter, and Kevin, we will be your hosts during the next 1 hour and a half. So we'll finish around 11:30. So with that, let's take it away. So here's the disclaimer. Just to make sure that content here is Red Hat confidential information, and it's for discussion purposes and can change for any or no reason. So the agenda for today is rather simple. We'll go through a quick introduction of DevSecOps. Then Edward will talk to you, kind of a build on the previous presentation around how to automate your security environment. By the way, if you were not there on the previous one, it's also not a prerequisite, so that's fine. Then we'll have Dieter discussing the security of your OpenShift cluster. And then Kevin will end with the application side of things. And I will follow with the best part of the presentation, the Tecton demo. And that's what you have when you present the intro. You can say whatever you want. So DevSecOps, basically what this slide shows is that in the market, it's seen as really critical for enterprises and will be there present in our future. Everybody is starting to adopt it at one level or the other. Another thing that's not on this slide, but I think we can all recognize, hopefully, and I for one do in the enterprise world, is that security basically was once purely seen as the task of the security department, and so the security department was highly abstracted away from the business and technical areas, and is often isolated within the company. So a recent comment that I can recognize from a real life customer was basically, well, this is a security concern, it's not our concern. That really demonstrates that divide within organizations, which can cause that kind of friction. So we'll review today the left shift of security more into development and operations teams, which is much more, which requires a much more joined up approach. And we will see how Red Hat can help at all of these levels. So on the infrastructure, containers, identity management, and all other various types of glue, which makes up a secure container platform. And just one moment. I'm just checking if everything is working fine because okay, good. Everything seems to be working fine for everybody. So then we can continue. These are the challenges that DevSecOps allows IT and security teams. Basically you can tackle these challenges and you will see throughout the presentation how we can improve the speed, reduce human errors, have consistent and repeatable environment, and basically also cut down on the silos and enable better collaborations between your different teams, dev, and so on. It can be a little bit overwhelming, so we can't tell you that DevSecOps is easy, but we will tell you that each individual step can be. So as long as you take steps, you learn to walk and then to run. So you start simple, you start with a small system, CI system like Tecton that we will review at the end, or automation using Ansible. And once you start building, the great thing about that is that since you're automating these, it doesn't require daily work to continue using it. So this frees up time and enables you to, for example, mitigate new security threats, which you haven't been able to address before. So every journey is different, but almost all start with implementing one or more forms of automation. So for development, as we will see, that would, for example, be a CI system, but for networks and systems, or it would maybe be a configuration management tool like Ansible, like satellites, and so on. And finally, in the intro, just wanted to share this kind of view of the entire, life cycle, where security has to be integrated with DevSecOps. And most organizations focus directly on the application pipelines, integrity of the libraries that are being used, code scanning, and so on. And we will look at those aspects. But we'll also look at the overall picture where underneath all of this, you still have an infrastructure that needs to be secure. You still have your Linux machines, still have your automation for that with Ansible and so on. And the green box around, that's something that we will focus less in this presentation, but the whole culture and process approach at enabling DevSecOps is very important. And keep in mind, that's also something that we can help. We have different programs for that if you would be interested. But with that, I will give it over to Edward, who will take you through the automated security part. And I think Edward will share his own screen, so we don't have to say next at every slide.
Thank you, Peter. I'll try to share the screen. So everybody should be seeing automated security. So what is security automation actually? Security automation is the use of technology that performs tasks which reduce human assistance in order to integrate security processes, applications, and infrastructure. That obviously is a very nice description, but let's dive in deeper. Automation currently mostly happens on different levels within a company, most independent of each other and only focused on specific historical tasks of a silo. If we want to take advantage of DevSecOps, this has to change. Security should be an integral part of all development and automation. We want to ensure that our deployment follows the proper order of operations to configure the environment as it will be in production, not only for infrastructure deployment, but also for security purposes, so that we can comply with the standards set forth by the CISO. In order to keep tabs on what's happening when the application is deployed, we need to update existing rules on several independent services. Finally, to be able to see the big picture of what's happening, we need to integrate all these pieces together so we have a holistic view of the situation. From a developer's perspective, let's consider bringing security practices and policies into the development workflows. Often we have a scenario where we have an environment that's provisioning a new minimal set of the production infrastructure, but typically details such as the enterprise security policies and devices are ignored. If you use Ansible to provision and set up the environment, we should allow for development teams to simply reuse the same security policies through the playbooks in their own development environments, such that they can test, just like in production, and validate and test that the network traffic flows correctly. This ensures that application developers are mindful of their application requirements from the security team while developing, and this avoids, obviously, issues when moving to production. Here you see a short example of a playbook that will add a rule to a firewall checkpoint in this case. Another example is making sure that the intrusion detection system knows which traffic is expected to reach your application and what not. Here we are creating an IPS sensor for 40 OS Something you will notice here is the amount of options we have. This is to highlight that we have capability with Ansible in many cases to take full advantage of all features available to a particular technology, while also providing abstractions for common use cases that all vendors support. Once again, from the developer's perspective, we're attempting to bring security into the DevOps workflow. We're able to dynamically add the logs from our new web app into Splunk as a log source and create a correlation search to enable the creation of investigations into Splunk Enterprise SIEM. While this is something we can incorporate in a continuous implementation environment, this is likely a more common scenario if you're in an enterprise infrastructure setting that does regular deployments to dev, test, stage, and production. We can assure during deployments to your dev and test environment that everything is coming into play in Splunk as you would expect for stage and production. So here's an example how we can improve security and compliance of infrastructure operations by securing the deployment infrastructure with automation. This all done in baby steps. With OpenSCAP, you can scan your images for vulnerabilities and compliance to make sure that all configurations are conform to the security rules that have been put forward. As we will be sharing these slides, I would like to ask you to check out this short video that shows you exactly how to scan a container image and obtain a detailed report of the situation. Here is an example of how to automate OpenSCAP scanning on multiple hosts. As RHEL discussed in the previous session, these scans should best be run on a regular basis. Hence, automating them makes sense. OpenSCAP is also integrated in Satellite, so you can assure your managed machines are compliant during their complete lifecycle. We first install the package required, OpenSCAP Scanner and the SCAP Security Guide. Then we run the scan, and the results of the scan will be centralized in one location. You can see that here in the code. The results of these scans can be then used to make the necessary changes to the OS of the container images. These changes that are required for your specific security requirements can then of course be coded in playbooks as well, so they can be reused throughout the organization. Red Hat has always worked hard on building secure systems, but human error and internal threats can still occur. When you automate the configuration of your systems, you can mitigate a lot of these issues as much as possible. The consumer of the playbooks you have written does not need access to the host, nor to the credentials required to make the config changes. Playbooks are one source of truth for the configuration and can be run regularly to make sure that all systems have the same config. Reporting will make sure that anomalies, like changed config on some systems, can be reported, as they might be an indication of a security issue. Due to the fact that Ansible playbooks are written in a very human-readable form, and that the implementation of what is effectively executed is separated, Ansible playbooks can in most cases stay the same even when deployments are done on different versions of the operating system. For example, RHEL 7 versus RHEL 8. Writing human-readable playbooks with specific tasks that need to be performed makes sure that, for example, during patching, no steps are overlooked. A huge collection of Ansible content is available through the Ansible Hub, with full support, and Ansible Galaxy, the latter being the location where community content is created and shared. So you see, it only takes baby steps to improve security and compliance of infrastructure operations. And remember, automation and analytics are the key to effective security and compliance. Some use cases were implemented in a hands-on lab that you can check out on the link on the slide. The foundation still is Red Hat Enterprise Linux. For common infrastructure deployments or cloud-native applications, the basis is still RHEL. RHEL has been built with security in mind. Security is of utmost importance during the build of your own specific operating system images to run your application, or when using container images like the Red Hat Universal Base Image as a starting point. But also during the deployment and maintenance cycle, your systems and applications go through automation can help to keep your infrastructure and applications secure. Insights, Satellite, and Ansible are all Red Hat tools that work together to keep your RHEL infrastructure healthy and secure. Containers, however, are not the same as virtual machines. Leveraging Linux features like namespaces and cgroups to isolate and limit resources, you don't run containers as a root. But if you need specific privileges, you can leverage secure computing to specify what is allowed by that container. Lastly, there is SE Linux. It's part of the RHEL operating system. SE Linux is an extra layer of defense and blocks unneeded access. For example, a web server does not need to access files in the home directory. So in case there is an exploit and a container would get root access, SE Linux can still prevent the container from accessing the host or other containers. And it is turned on by default. Here we have some examples where SE Linux was able to mitigate the security risks through mandatory access control architecture that provides a fine-grained level of control over the files, processes, users, and applications in the system. Thanks for attending this session, and I'll give the word to Dieter.
Thank you, Edward. So I'll share my screen. Here we go. So how about securing an OpenShift cluster? So yeah, as you might know, OpenShift is the platform to deploy modern applications, cloud-native applications, but you can also use it to deploy more traditional VM-based applications. And the main components are Red Hat Enterprise Linux COREOS and Kubernetes, and OpenShift has many layers, many layered services on top of that. I'm not going to go into detail about that, but often we get a question from customers like, now how do we make containers secure, or how to make the platform secure? And sometimes they have something in mind, some topic in mind, but there is no like 1 minute answer, and there are many aspects where you want to take a look at. And we have divided those in 3 layers, let's say. So first there is the control layer. You want to make sure that you have control over the application that you deploy on the platform, that you can trust the application, starting from the base image and the whole CI/CD pipeline, where you can include some vulnerability scannings, and a container registry where the image is located. So that is a secure and enterprise-ready register. And Kevin will talk about the control layer later on. I will mainly talk about the defend layer, and that's really about how to defend the platform itself. And even there we have multiple topics that we can talk about. You can talk about networking, you can talk about storage, the host itself, and so on. And then the third layer is the extend layer, and that's with that we mean actually our ecosystem. So Red Hat has a big ecosystem of certified partners. So they have a third-party product that integrates with one of our products, and there are many partners that have a security-related product that integrates with OpenShift and that you can make use of. So I'll go over the defending the infrastructure itself. I have a number of topics, and the first one is configuration and lifecycle management. We want to make lifecycle management and configuration as easy as possible. And the way that we do it is through automated operations. And why is this important from a security point of view? Well, the harder that it is to install something or to update or configure something, the more likely people or organizations will make errors doing that, and the less frequent they probably want to do that. And it's of utmost importance to always keep up with patches, security fixes, and so on. So if we can automate that, it will be much easier to deploy a new version. So we make things secure through automated operations, and we've talked about it before. We use the operator framework for that. Operator framework has similar ideas to site reliability engineering. Frequent operational tasks can be automated. So instead of writing a whole playbook with step-by-step steps that you need to execute manually, you can just code the whole thing, and in this case put it in a container that does it for you. So things like deploying an application, applying patches, updating, rebalancing a stateful application, fine-tuning settings, all those things can be automated and is put into a Kubernetes operator. So you can create operators for your own applications, but we heavily use operators internal in the OpenShift platform. So think of machines, for example. So machines need to stay up to date with the latest patches and feature releases. And the first thing that you need to do is deploy the machine. If you're familiar with the IPI or the installer provisioned infrastructure way of installing OpenShift, well, the installer will actually create machines for you, and afterwards there's a machine API operator that can create new machines for you. So if you need to scale out in a public cloud provider, for example, then you can just go through to the web interface, click a few buttons, and new virtual machines are spinned up. Next to that, there is also another operator, the machine config operator, and that one is going to apply patches and updates for you, so you don't have to do that. COREOS has a mechanism to update the operating system and reboot into a new version. And the machine config operator will also apply the configuration to your machine. So if you need to set a different NTP server, if you want to set some specific kernel arguments, some other configurations like you want to limit the max number of pods deployed or the max limit on the number of processes, you're not going to SSH to a machine anymore and change the configuration files in there. No, from OpenShift, you actually create a custom resource that the machine config operator will use, and then the machine config operator will apply it to all your nodes. So that way you make sure that the config is consistent on all your nodes, and the machine config operator will even revert any changes that you make manual. So you can still SSH to a node for debugging, but if you would change the config file, the machine config operator will revert it anyway. And if you would scale out either via the web interface, or if you have a UPI deployment, you create new machines yourself, the machine config operator will immediately apply the same configuration in that new machine. So you don't have to worry about drift, you don't have to worry about making mistakes there. Similar to configurations, we want to make things as less risky as possible. Everything is in custom resources, and you can put those in Git. It's a good practice to do that. And then the software lifecycle management, I've talked about that. So we have the IPI, UPI deployment. We have over-the-air updates. So by just clicking a couple of buttons, you can do an update of the whole system. And if you don't even want to be bothered by machine configuration of the lifecycle management of the platform, there are still managed OpenShift platforms. We have OpenShift running on different cloud providers. that you can just order pay by the hour, and you don't have to worry about doing the lifecycle management or the installation of the platform. So that's also an option. The second thing I wanted to talk about is host and runtime security. And Edward already talked about the components in RHEL for containers. So one important aspect is as a Linux, for example, that already prevented people to use a specific exploit and take over the whole system. But we also go one step further. So we've stripped down Red Hat Enterprise Linux to RHEL COREOS, created a minimal Linux distribution, which is specifically optimized, or the only purpose is to run containers. So that decreases the attack surface. So you don't. So what we don't need is removed, let's say, and makes it more secure. RHEL COREOS is immutable or semi-immutable, let's say. So all the binaries are read-only. You would need to replace the whole volume to if you do an update, and the configuration files are read-write, but as I said, those are managed by operators. So if you would change that, those changes would be reverted, which makes it pretty secure. Never run containers as root. So by default, normal users can spin up containers, but they don't have any extra privileges. Only an administrator can have or can spin up containers with extra privileges. But even there, even there you have the option to specify using secure computing what privileges are allowed. So you don't have to give the full root access to a specific container. You can define that more granular. Then the next thing is identity and access management. So as you know, OpenShift is multi-tenant. You can create multiple projects. They isolate applications across teams, groups, departments, and so on. And then if a user logs into the platform, there is an OAuth server that where you can actually, that is used to identify that person against one of the identity providers that you can use. The user is mapped to an OpenShift user and gets a token. And then the next step would be authorization. So you can very granularly define for each user what that user can do. Actually, for each object or each custom resource, you can say this user can get an object or list all the objects, create objects, update objects, delete objects, and so on. I don't mean objects, custom resources in OpenShift or Kubernetes terms. There are some, you can create roles and apply those to the users, but there are also some predefined roles. So there are cluster roles and local roles, so related to a specific project. So you can be an administrator of your project without being a cluster admin, for example. Then there is data at rest and data in transit. So internally in OpenShift, there are many different components talking to each other, and for that, certificates are being used. So there is a root certificate authority in OpenShift that creates a certificate for all these components. So communication is encrypted for many of these things, and those certificates are automatically rotated. Right now, it is not possible to change the root certificate authority. What you can change is actually for external endpoints, like the ingress router, you can configure your own, or you can create your own custom certificates. So, for example, there was this blog post about OpenShift running on Amazon that you can actually use Let's Encrypt to have to encrypt the access to the console and so on. Then there is secret management. So never ever store sensitive data in your container. Things like passwords, SSH keys, or certificates. Rather create a certificate object in or custom resource in OpenShift, and then or work with an external or third-party vault. And then when the container is created, the secret is made available to the container as an environment variable or a volume mount, and so on. If it is stored in the etcd database, well, secrets by default are stored in the etcd data store. etcd can be encrypted, and there is also encryption in transit. The secret itself is never stored on the node. So if it's passed towards the container, it's done using a temporary file system which runs in memory. That is removed obviously when the node is shut down, but also when the container is removed. So it's never stored to a disk. Now you are still able to encrypt the whole disk of your masters, of your workers. So if you want to prevent somebody from, or if you want to avoid that somebody can go into your data center, hopefully it's secure, but go into your data center, pull out the disk, runs away with it, and then get some sensitive data, you can encrypt the volumes of the OpenShift nodes. With Linux, you have LUKS encryption, but well, when you do that, you would need to, when you boot the machine, you would need to enter a passphrase to decrypt the volume. That's not very practical in cloud environments, or when you have a lot of nodes. So for that, you have network-bound disk encryption. So the volumes are encrypted. When the machine boots up, it's actually going to connect to or doing a remote call to a decryption key server, and then when the keys match, the volume is mounted. So that's something that you can set up if you need to. Logging, monitoring, and metrics is also an important part when it comes to security, because well, in some cases you might want to figure out what is happening. So, well, when it comes to logging, there's the EFK stack. So all the logs are forwarded to an Elasticsearch. And there's access control in the sense that a cluster administrator can view all the logs, and individual users can only view logs of their projects or containers they create. And that's a pretty powerful aspect of this platform, in the sense that a developer, if something is going wrong with a container, the developer can access logs of that container without having the need to log into one of those nodes. You can just see that from the console. Those logs can also be forwarded to somewhere else, like a seam. There are multiple metrics being collected from different things within OpenShift. We have been improving that over the past year. So and you can also create alerts and silence those and so on. Then there is audit and compliance. So one of the nice things when you use OpenShift with Quay or the Quay operator is that Quay is our registry, and it has actually a container scanning tool called Claire. And these results are now are available from the OpenShift console as well. So as an administrator, you can actually see what vulnerabilities are actually in my containers, or if you click on a vulnerability, you can see which containers have that specific vulnerability. So that's, I think that's quite useful. I already talked about the machine config operator, which prevents you from getting configuration drift on your machines. The machine config operator will always make sure that that configuration is or your nodes are correctly configured. And then there is the another useful operator, and that's the compliance operator. So the compliance operator is an OpenShift operator that allows an administrator to run compliance scans and provide remediations for the issues that's found. And the operator leverages OpenSCAP under the hood to do that. So that's a tool to scan and enforce security policies. It scans both the cluster and the worker nodes against the predefined or against the defined profile. And when you install it, there are a couple or a few profiles available, like the SCC OpenShift benchmark. But you could also create your own profile or tailor an existing profile and pick the rules that you want in there. Then the last thing is defending the network. So OpenShift has a software-defined networking in the platform. It's called OpenShift SDN, although there is a second one right now, which is called OVN Kubernetes. Both of them are making use of overlay networks, either VXLAN or Geneva. And actually, that separates the traffic, and together with the Open vSwitches on the nodes, that completely separates traffic between different projects, for example. The network itself is not encrypted. If you want to have encryption between your microservices, I advise you to look at service mesh, which can do that for you, and is also included into the OpenShift container pods. With OpenShift SDN and OVN Kubernetes, there is support for network policies. So by default, within a project, all the pods can talk to each other, pods and services. But you can actually very granularly define, well, up to layer 4, so protocol and port, what is, which kinds of traffic is possible or not. And if you want to use something else than OpenShift SDN or OVN Kubernetes, you can also make use of one of our third-party plugins. So network vendors that create a CNI plugin for OpenShift, you can use that. Another way of segregating network is by using Multus. So with Multus, you can create pods with multiple interfaces. The first one is always connected to OpenShift SDN. The second one or the third, fourth, you can configure. So you could directly connect the pod to a network interface of the machine itself or a Linux bridge and create like a private network, let's say that way. And then the last thing is API management. So if you want to expose your services to, or the services that you create are for your customers, and you need some extra features like authentication, authorization, LDAP integration, access controls, rate limiting, and so on, you can take a look at 3-scale API management, Red Hat's 3-scale API management that can do these things for you. So that was the defend layer, defending the platform. Just a brief introduction to this extend layer, so extending security with the security ecosystem. I'm talking about third-party vendors that have a tool for identity and access management, third-party vaults, encryption tools, container runtime analysis tool, a SIEM, vulnerability scanners, and so on. So we do have many partners that have a certified operator to integrate their product with OpenShift. So definitely worth to look at those and see how it integrates. One last topic is you might have heard about the Red Hat Advanced Cluster Management for Kubernetes, which is a tool to manage multiple OpenShift or Kubernetes clusters, do lifecycle management of those clusters, do lifecycle management of applications on those clusters, and get it all from a central or manage that all centrally. The Advanced Cluster Management for Kubernetes also has the option to create policies, do some risk and compliance on those different clusters. So you get a notification when when one of your clusters is not compliant with what you have defined. With that, I will give the word to Kevin. Thank you.
Thank you, Dieter. All right, so so far we've focused on securing the systems, securing the platform, but of course, we also need to focus on what we're actually going to be running on that platform, right? So application security definitely plays a role here, and so I'll be focusing on that. For those who don't know me yet, I'm Kevin. I'm a solution architect, just like Dieter, just like Peter and Edward. But my background is in software development, so I've, most of my career was in software development. So, my angle is a little bit different, if you will. But anyway, we're talking about, of course, applying security, DevSecOps, kind of around the OpenShift environment, but not only, right? But what really is DevSecOps, and why do we want that? And, so when I think about earlier in my career as a developer, the way that we saw security people was, those annoying people that sometimes would come and complain, or they would block us from accessing things that we wanted to access, or they would come with this big list of results from a pen test that all of a sudden we had to push everything to the side and focus on that. So we saw them kind of as annoying people, of course. And then same with operations people, those were the people you had to wait for, right? You had to wait for, if you wanted a new environment, you had to wait several weeks for VMs to be spun up, or a database, or any other tooling. And so with DevSecOps, the idea is that, we all work together. And so we're going to tackle new projects or new features together. So we're going to create our user stories together. The security people can have their input and can be part of that development process as well. So, the operations people can provide self-service tooling so that developers don't go around them and find other tools. And security people can provide tooling, can provide base images and everything, and make that part of a constant feedback loop to immediately get ahead of security issues without first developing your application, deploying it, and then finally realizing, well, there are issues. Now we need to go back and fix everything in the 11th hour, and waste a lot of time because now we don't really remember what we did a couple of weeks ago. So that's not the most ideal scenario, and still pretty common, right? In a lot of organizations, that's still how it goes. So we need to focus on bringing that feedback loop closer and shifting our security left to the start of when actually everything is happening. So when we're talking about application development, the first thing is, of course, securing our code, right? So what are some considerations that we should take during our software development lifecycle? I think number one is training your developers in security topics. So in my career, I've seen many times that the developers just were not trained. I think I saw several times, just really simple kind of SQL injection issues, or just very basic things that developers just weren't trained on. And then the more senior people can train based on their experience, but that's not really the most ideal way, right? So training your developers in security topics is hugely important to get ahead of issues, to get that understanding of how should I write my code in a way that we're already going to get ahead of a lot of these issues. We should think about security during our planning phase. We need to think about doing some sort of threat modeling, doing that together with operations, doing that together with security, and not in our own silos. So we're thinking about some sort of gap analysis. We think about if a hacker is able to compromise a container, will he be able to compromise the entire system? If somebody is able to compromise one node, can they compromise the rest? Do we have databases that we're accessing, and should we think about the statements that we're writing? Is there going to be input from forms or whatever, just like Romuald was talking about in his session, and if so, how do we handle the input from those forms, and so on and so forth. So those are things that we should talk about when we're planning. And then we should use tools as we're developing that discover issues early and often. So there's tools like dependency analytics, where you could get immediately in your IDE as you're writing code, you're importing a dependency. It'll tell you immediately, hey, this dependency actually, this version has some vulnerabilities. You probably don't want to use this version. Whereas if you don't use things like that, then again, by the time you're actually scanning your code in your CI pipeline, best case scenario, or after it's gone into production, and then you have to go back to fix those dependencies and then realize, well, there's other dependencies on those dependencies, and now I have to refactor my entire code. That's not really the best scenario, right? Self-service provisioning. So if developers can get access to self-servicing their projects or tools that they're using, let's say we need a service mesh, or we need a new environment, a new project. That's easy, right? In OpenShift, you can just make that available to developers, and that allows, or that prevents a lot of the shadow IT where developers have to wait for something and then end up just going around and getting Docker images from somewhere, or they're getting tools from somewhere, and then that's not been vetted by anybody. Committing early and often. Looking at peer reviews during pull requests and merge requests, to again have somebody else look over your code and have another view over what's going on, and committing early so that every time you have a small component ready, just push it so that when you have to go back, you know exactly what particular components you need to fix, and not have this big commit that you have to think, where are all the different components that we affected. And if there's a security issue, now we need to refactor everything, right? So testing everything, that's kind of a given, right? So automating your testing with unit testing, but also BDD, so business-driven testing. So that doesn't necessarily mean the business needs to write these test scenarios. I don't know if you're familiar with something like Cucumber, where you're saying, as this particular user, when I do this, then this should be the outcome. That can be perfectly adapted to security staff who writes, as a security person, when a DDoS attack comes in, I want to make sure my systems are resilient and can handle that. When somebody uploads a binary, I want to make sure that that doesn't compromise my system. So you can write those kinds of tests that the developers at least have to think about as they're writing their code. And then, of course, automating everything. CI/CD is hugely important, to not have that human factor that goes and changes something on the fly that could potentially compromise an entire system. Having a consistent feedback loop, having consistent testing that you can rely on is hugely important. And also things like very regular pen testing, and ideally from a third party, so that you have somebody else that has a different view over security test your systems on a regular basis, so that when there's a problem, that you can get feedback to that. So with regards to that training, just real quick, Red Hat has, of course, some trainings. You absolutely don't have to do it from Red Hat, but I just wanted to point out that we do have some security training and certification for example, securing containers in OpenShift, to security in Linux, and in identity management and Active Directory integration. So there you go. There's some training that you can take. And with regards to the analytics, the dependency analytics, there's a tool that Red Hat provides, which is free. You can go to developers.redhat.com. And there's plugins for most main IDEs that you can just use in your IDE to get that feedback of what dependencies are there, and do they have any vulnerabilities, so that I can immediately change that dependency as I'm developing and not have to go back to what I already did. So that's securing your code. Then the next part, you build your code and into containers. Now you need to think about, how are we securing our containers? So again, containerization gives us an opportunity to shift security left as well. So if we start with using trusted sources for our external content that comes packaged in containers, that gives us more confidence than just going to Docker Hub or some other registry to pull down any kind of random image that we find that may be exactly what we want, but it hasn't been tested, hasn't been stabilized, and hasn't been vetted by our security staff. Probably not. So we need to make sure that we use trusted sources because you never know what's in those images. Maybe nothing malicious, but there might be vulnerabilities in there that could be exploited. So you want to use a private registry to, typically to pull down your images, kind of a gateway to external registries. So building security gates in your CI/CD. So as you're going through your CI pipeline, having a step to do analytics of your code, something like SonarQube. And then scanning of your containers, those should be, OpenSCAP testing and so on and so forth. That should be part of your CI/CD pipeline to, get that feedback as soon as possible, as left as possible. And then the rebuilding and redeploying one is an important one too. You never want to patch a running container because, it's again a manual intervention into your system that you don't want. You want to have everything in your code repository so that you have it, you can go back to it, you can revert it, you can inspect it, and so on and so forth. So in terms of the external content, Red Hat has a container catalog that has quite a few images that you can use that have RD tools built in. So for example, here there's a Python image, and it'll give you a health index of that particular image. So we're constantly scanning those images and then posting the health index. So for example, A, means there's no kind of high or critical vulnerabilities in that image as of today. And then B, C, that's probably may have some small vulnerabilities that may not directly impact you, all the way to F, where you probably don't want to use that image until it's been patched. So that's available to Red Hat customers. The Red Hat Universal Base Image is a base image that's based on RHEL, of course. That's available for everyone at no charge. Has a minimal footprint and has been tested, has been stabilized by Red Hat. And so it's a great starting point to build your applications on top of. There are UBIs, Universal Base Images for for Python, for OpenJDK, and so on and so forth as well. And then as Dave already mentioned, for the container registry, we have a solution at Red Hat, the Red Hat Quay Enterprise Container Registry. You're of course welcome to use any container registry that you would like, and you can integrate that. The nice thing about Quay is that it has Claire scanning built in, so you have again feedback of what's going on in your containers in terms of vulnerabilities, and it does that on a continuous basis, right? So it's not like when you push your image, at that point we're going to do a scan. Quay will keep track of, if there's a new vulnerability coming in, you can see, well, actually in those images in the registry, that image has that vulnerability, so please be aware of that. And then you can integrate that in your OpenShift so that right as you're running your systems, what's if there's a new vulnerability, those images are actually a problem, and you can patch that, through your pipeline, of course. For example, by having your security experts patch a base image and provide that in their pipeline that integrates with the main development continuous integration pipeline. And then moving forward, so once you have your code built, you have your container images built, now you also need to secure your application integration, right? So integration between different applications. And Dieter already mentioned, you can do that on a network level in OpenShift. And you can do that with things like an enterprise API management solution. And then inside OpenShift, as Dieter already mentioned, we also have the service mesh components where you can add, zero trust network from within your system, so that, if anything gets, if you have for some reason a man-in-the-middle attack that came in through one particular container or something, that if there's somewhere in your network any issues, that doesn't necessarily mean that your entire network gets compromised. So securing and encrypting the traffic between different pods and managing certificates and so on and so forth without having to build that specifically in the code, but having that managed by a central control plane. And automating, of course, goes hand in hand with security, right? So without automation, you really can't have a secure pipeline, or you can't have a secure delivery of your applications. If you're going to do it manually, there's always opportunities to make a mistake. We're humans after all, right? And automation in software development, of course, goes hand in hand with security in your CI/CD pipeline, right? So if you have a CI/CD pipeline, usually you would use trusted repositories to get your code from, trusted repositories to get your dependencies from. Typically, you don't want to pull them directly from the internet, like I already mentioned. So from the development, you push the code, it goes into the CI pipeline, do your unit tests, so those cucumber tests, the business-driven development tests where the security staff could, for example, have stories that then match with your testing, with JUnit, with Arquillian, any kind of testing that you're doing to test very specific components that they work exactly the way they expect, both in terms of functionality, but also in terms of, what kind of rogue inputs can I possibly come up with in my testing. Then once that's, once that passes, you go on to your code quality testing gate, where you test, is my code, up to snuff in terms of, vulnerabilities. So tools like SonarQube or Coverity can be handy there to be testing your code. Also, in terms of compliance with, your test with your code standards, if there's code smells or anything, it can uncover those, and then you can set a certain threshold to say, if it's 80% compliant, then we can let it pass in terms of code quality, let's say. Probably in terms of security, you want to set it a little higher than that. But then you can stop your pipeline at every step of the way, and if there's any issues, you stop it right there, you go back to development, they fix their issues, and then you get that quick feedback loop of what's going on. Then that next step, security scans, and as you can see, there's quite a list of providers. So have your pick, if you will, of security providers that you can work with. So in terms of OpenSCAP, that's easy because it's purely an open source community project. You can use Quay with its container scanning, thanks to the Declarative component. You can use any of our partners like Aquasec, CyberArk, StackRox, which I guess is not quite a partner anymore. I don't know if you've heard of the acquisition of Red Hat. So we purchased StackRox, and that will be an additional offering with OpenShift. But you really, have a lot of possibilities here, and I highly recommend scanning your container images before you move on in your pipeline. It really gives a lot of insight into any kind of vulnerabilities that are in a container image. Then, integration testing, so testing, making sure that everything works together the way that it's supposed to. QA testing, UAT testing, that can be automated, and that can also be triggered by, security test scenarios that they build. Any kind of, they can build tests where they pretend to inject any kind of, binary into a form that you have in your systems. And then from that point on, if everything is good, you have quite a bit of confidence that, you know, everything is as good as it can be, right? So you have so many steps along the way automated that you can, you know, at least have confidence that we did what we can possibly do, especially if you then respect those you know, the best practices that that Edward and Dieter talked about in terms of system and platform as well. Then that deployment to production, or not necessarily only production, but also to your testing, to your integration environment, to your UAT environment. You can do that kind of in a more traditional way as part of your CI/CD pipeline or manually, but really you want to go down more of a GitOps way of deploying, where all your resources, all your components are defined in Git as well. So you have exactly, you see what's going on, you can revert, you can have multiple eyes on the configurations. And so GitOps gives you that capability. Before I move on to that topic, I just wanted to point out on the production side there, you can also see that there are those security providers again, because it's not just because during the time of the deployment that everything was okay, that there were no vulnerabilities. That doesn't mean that, you know, any kind of new vulnerability comes up that that you can just kind of let go, right? So you need to constantly have something that checks what's going on in your production cluster. Are there any new vulnerabilities that we should be taking care of? And then again, going through that automated process that makes it quite easy to then automate and renew what's happening in you know, what you're running in your systems. So in terms of GitOps, and maybe you've heard of this, maybe not. So OpenShift has also announced, well, Red Hat has announced that we now have an OpenShift GitOps component. So this is based on Argo CD, but it's supported, it's stabilized, it's secured and by Red Hat, and it's part of the OpenShift offering. So that's another, just like Service Mesh, just like serverless. If you purchase OCP subscriptions, you can use OpenShift GitOps, which, like I said, is based on Argo CD, to really define all the components that you're deploying. So configurations of your Kubernetes cluster, any kind of node tuning, any kind of machine configuration, you can define that in code, have that be deployed in Argo CD, and you can integrate that into your pipeline, really automate and stabilize your deployments in your systems. So with that, I will give the word to Peter, and it looks like we're well on time, so he can give you a really nice deep dive into an example CI/CD demo that focuses on a few of the components that we talked about. And yeah, so go ahead, Dieter, or Peter.
Only one letter difference, huh?
Yeah.
Hey, thanks, Kevin. I'll take over the screen, and it's good that we have a bit of time. We might end up a bit ahead of schedule, but I guess that's better than being over schedule. So we'll see. Let me share my screen, and we'll take you through a live demo. So hopefully everything goes fine, but it should. So okay, share screen. So if you can just confirm that I have the right screen, someone, just to see that you can see the pipelines view here. Okay,
That's
thank
good.
you. So basically, what we've done here is built a small demo using Tekton and integrating Quay, and we'll see also a little bit of OpenSCAP. Thinking about the start small that we discussed a couple of times in the presentation, I think this fits very well into that scheme. So as probably many of you, COVID times were very, very busy. So this demo was put together in I would say 1 or 2 days. So it's a small Tekton demo, but it has the advantage that you should be able to quickly see an overview of Tekton and kind of grasp also. I will show you a little bit of the code as well. So hopefully you get a good understanding also of Tekton. And for those that don't know Tekton, a small introduction. It's now in tech preview as OpenShift pipelines in OpenShift. And it's a way to do CI/CD where every step of the pipeline runs in its own container as well. So we will see a bit how that looks like. So you can see here, I already have created a pipeline, and it's failed, and that's normal. So let me just open it, and then we'll see why it failed. So here you can see on the screen here that it shows a little graphic of the pipeline. So that comes standard. I didn't have to make that graphic, right? It comes from the definition of my pipeline, and it's auto-generated that way. And what we're doing here is we are deploying a Knative application, so serverless. Not really important to understand serverless in the context of this demo, just we're deploying basically a container-based application if you want. So I'm fetching a repository to start, so Git-based repository. Then we'll build an image. And you can see here that it branches into two. Once we have the image that's built, so using the build tools of OpenShift, source to image tools, OpenShift will build the image for us. And once that's ready, there is a task that will look at the OpenSCAP, so the OpenSCAP scan task. And then in parallel, we'll push it to our Quay registry. So I believe Kevin introduced Quay as well, so which is a secure registry. You can actually also use it for free. You can go to quay.io. As long as your repositories are public, it's free to use. So, but we will see also the UI of that. And then we scan the results. So we scan the results of the vulnerability analysis that Quay has done. And that's where the pipeline can fail. For example, if your image is insecure, we will fail here and say, no, don't deploy that application, it's insecure. And if it is secure, we will promote it from dev to prod, because initially the image is built with a dev tag on it. And then we will deploy it, and then we will see the results. So that's what the pipeline looks like. If I now go back here and look at the last run, I can see pipeline run details. So I can see that my fetch repository went well, build went well, OpenSCAP task went well, push to Quay went well, but I have an issue on my scan results. And immediately here I can also see the log snippets. So I can see that that image has a couple of vulnerabilities that were detected by Quay. And depending on the threshold that we've set, so this is a small script that Kevin has written in Python looking at the vulnerabilities. And here we are not meeting the threshold, so we're marking it as unstable. So one of the ways we could, for example, pass the scan is either to change our threshold, which, depending on how secure we want this environment to be. What we will do in the demo here is actually change and fix the base image. So we will see that. And actually, let me do that now so we can already run the pipeline and look at some other things like the OpenSCAP reports while the build is running, because we are a bit dependent on the Quay vulnerability analysis. So when you push an image to Quay, on its own, it will do vulnerability analysis. It gets queued. Since it's a SaaS service, it gets queued. We don't really control exactly how fast it's going to run. But we'll run it now, and then normally by the end of the demo, we should have a functioning build. So what you're seeing now on my screen is the YAML describing the image build, and you can see it's been built using this image here. And I'm going to change it to an image that I've built, which is hosted on my repo, and basically which fixes the vulnerabilities of this image, and we will see in a second what these vulnerabilities were. I'm just going to stage that. I'm going to commit it, fix my image. So it's pushing this to the Git repository. And basically the pipeline is looking, is pulling this file from the Git repository. So now it should use that new image basically. I'm going to open my terminal and I'm going to just, on my second screen, you don't see that, but I'm just changing the name of the pipeline so we don't overwrite the previous one. I'm just creating a new run. I will show you. So we're just applying that. Wait a little bit for it to accept. There we go. So now I will just go back here in the pipeline section and I will show you, you see now we have the last run and it's kind of running. I will put it up here, in small so we can follow the run as I present the other stuff. Okay, let me move this one to a new window. So we were talking about Quay. Here we can see the repository, and you can see that the dev has a high. Latest here has passed the security scan. That's because I've run the build already, but actually we could quickly delete this one, delete tags, and it will repopulate. Once it gets, again, promoted to production, it pushes a new latest image. But here you can see, so on Quay, you can see the different vulnerabilities that you have on your image. And here we can see, okay, we have some issues with the Node.js packages. These are the CVE names. It's fixed in this version. And so that's what we can see here. So, and that's what we're using in the script, in the scan results. Once, we have deployed with the previous build image, which has these vulnerabilities, then we end up in this situation where the pipeline is stopped because of these vulnerabilities. So also what we did is do an OpenSCAP scan of our image. So here I will open up the results. We did 2 different scans. There we go. And so you can see here we have the OVAL results, which came up pretty good. There is no real problems here. It's a bit small. Yes. Okay. Let me. Yeah, it's true. My resolution is pretty high, so indeed, I will make it bigger. Is this kind of font okay-ish?
Yep.
Okay, so basically here we did the scan of the container using OpenSCAP. So you can also scan containers using OpenSCAP. It's scanning the image and telling you if there's any vulnerabilities and linking you to the CVEs. Next to that, you can also do policy type scanning. And we've done that as well for this image. And we've used the PCI DSS control baseline, which is typically used for the financial markets and I believe the U.S. Department of Defense uses this, and so it's a pretty serious set of rules that is going to check if your configuration of your operating system matches these policies. And here we can see we have a couple of issues. So we're not going to attempt and fix them all, but that would be ideal if you have to follow the PSI DSS, obviously, or we're going to fix one to prove the point. So here we can see that we have, for example, the prevent login to empty where there's no password. So if an account is configured, you see you have description of the issue with a rule, an identifier, and so on. And you can see a description. So if an account is configured for password authentication, but does not have an assigned password, it may be possible to log into the account without authentication. So it says you have to remove blah, blah. We can actually look at the scripts here. So we have an Ansible script, OpenShift script, or a shell script. In this case, we're going to fix the image. So I'm using the shell script, and you can see we have a couple of set commands. So how are we going to do this? Now, so what I've done, so now you can see the build has been pushed successfully here. But what we've done is when building this image here that we've used in the new build, we've used the following Docker file. So we're pulling the original image and we're not updating these packages because we actually don't need NPM or Node.js. So we're just removing those packages, and we're also applying what is suggested here, these couple of set commands. And then we're just rebuilding that image and deploying it, as we've just done. So after the deployment, so we can see it has worked, I can now go to my QA, and if I refresh here, and maybe I make this a little bit bigger too. So you can see we have now, and it's too big because, we have now the latest and the dev, which have both passed the security scan. And that's because we fixed the build image, and we've fixed the issues that were, we've uninstalled NPM, so effectively there's no more issue there. And similarly, if we rerun the OpenSCAP scan, and I'll bring up the results right here, if we go down, we will see that in the same section, the prevent login to account with empty password is now a pass, because we've applied successfully the fix that was suggested here. So that's a pass. And now we go back to our pipeline here. And again, we see the result. Something that I wanted to mention also earlier, you can have a look at the logs as well for every step. You can see, for example, here the latest step, what happened. I have deployed the service. This is the URL. In terms of scan results, you can see the scan results are empty because we don't publish anything when it's empty. There's no vulnerabilities. And so on. So you can really look at all the logs of the different containers in the different step of your pipeline straight from the UI. Right? Obviously, you can also do everything on the CLI, but I thought for the demo, it's nicer to see it in the UI. So now maybe we can review a little bit the pipeline. So this is actually the code of the pipeline. So I'll open here the YAML file describing the pipeline. Keep in mind, again, starting small, starting fast. This was built pretty fast, so the code hasn't been polished. We're not using any kind of config maps or stuff like that. But basically, here you have the Tecton pipeline definition that you can see, and you have all of your variables which are required as inputs. So we need a Git URL for your application, we need an image name, the registry, namespaces in which we're going to deploy our OpenShift project, and things like that. And if we go down, then we have the list of tasks. So we have the first task, which is fetch the Git repository. So as we've seen in the UI, right? The name is here. And this is a task that comes with Tecton. So Tecton gives you out-of-the-box tasks, but you can also then create your own tasks for things that are not out of the box. Fetch the repository is an open out-of-the-box task. And so we just give it the URL and the revision, and then it will pull that Git and make it available through a workspace, as it's called, to our other next task here, which is build. And so build here is a custom task. There's also out-of-the-box tasks for build-up, for example. This is leveraging build-up in a slightly different way. And so this task runs after the fetch repository. And then we have the push to QA, which is, again, an out-of-the-box task using Scopio. And so you can see here the source image, test image, and we can see it runs after build. And here you can see we have the OpenSCAP scan, which runs also after build, meaning it will run at the same time as the push to QA task. Hence why on the graphic it was kind of split there. We had the task running in parallel. And then you have the scan results, which is running after push to QA, your dev to prod, and finally the deployment. So just to show you, for example, one of the custom tasks, if I take the build, for example, this is what it looks like. Here we're just using a simple script, also kind of quick and dirty, I have to say, but you can see that how you can make custom tasks, take arguments and things like that. And then finally, once we have created our pipeline, we have to create runs. And this is what I was doing on the screen when you were not, when I said I'm doing that on my second screen. I fixed here the name. So this is the pipeline fixed that I've created. I've changed the name here. so that we don't override the previous one, so that we can still see it. But obviously, you can also overwrite it. And you can see here I'm using service account names for my Quay credentials. And here I'm giving it the values of the different parameters, my Git URL, and so on. So that's it for the overview of the Tekton pipeline. I can show you also the Tekton Hub, where you can find all of these out-of-the-box tasks. So for example, we've been leveraging Scopio, and I can open Scopio, and I can see a description of what this does, a YAML, but I can easily have the install to install that task and be able to leverage it in my Tekton pipelines. So that's it for this small demo. Actually, we've seen the broken state, we've seen the working state, and we've seen the different, the vulnerability scanning from Quay and from OpenSCAP. Sorry. So I think we'll share the code at some point. I'm going to keep polishing it, and we're going to build on that. And you're probably going to see more and more things added to this pipeline as we go along. As everyone in the DevSecOps journey, I am as well, and we are as well. So that's it for today. I think we will close the session 8 minutes early. Hopefully you had a good time. I will stay online a little bit if there are any questions. And otherwise, see you in a few for the final day of the Tech Month.
Yeah, thank you, Peter. Excellent demo. Maybe we can address the questions that were asked. I noticed they're already answered in the chat, but maybe we can address them real quick. I'm trying to track them down again. So the first one, and I hope Dieter is here still because he's the one who answered them. The first one was the distributed store is kind of a secured vault store.
Yeah, hello. So when you talk about secrets or configuration, it is in the etcd database of the OpenShift master, yeah, you can encrypt that database as well. So in that sense, it's a secured vault. Now, some of our customers, they already have a third-party vault in place that they like to reuse, and I'm thinking about, I believe CyberArk is one of them, for example. You can integrate those third-party vaults with OpenShift as well. So that's just another option.
Okay.
And then I'll continue with the next question, which was about file system encryption. So you can encrypt the volume. Well, you can encrypt both the etcd data store, as I mentioned, but you can also encrypt the COREOS volumes. The data store is not used to encrypt the volumes, so there are separate servers used for that.
All right. Are there any further questions? Type them pretty quickly. Otherwise, thank you everyone for joining. Hopefully this was useful. Yeah, again, hopefully next Tech Day we'll be able to meet in person and share some stories. Not share a drink, but have a drink together. And yeah, don't see any further questions. All right. Thank you, everyone. Have a nice day.
Have a good one, everybody.